So welcome to Fractions. This is my corny title is Nix the Tricks and Focus on Understanding. Before we begin, it would be great if anyone who has joined already, if you could just put your name, so rename yourself and put your name and the grade level that you teach next to your name. So for example, my name is Tine and I teach 6th grade, so my name is Tine 6. I'm going to put us into hopefully some vertical groups when we do breakout rooms, and that will help me to break us into vertical groups. Thank you. Okay, so welcome to the session. I know how busy everyone is right now. I'm teaching 6th grade. It is an insane year, and so I really appreciate you taking the time to come and do this work today. So the target for this session, we're going to gain a deeper understanding of the ways in which we can work to help students have a deep understanding of what fractions can represent and how to reason about fractions. Fractions are my very favorite thing to teach. I taught 5th grade for 15 years, and I obviously had to teach a lot of fractions in that time, but I just love them. I don't think I really had a clear understanding of how fractions worked or what they meant until my work in VMI. And I think that's one of the reasons I love fractions so much, is that I really got to know fractions and understand what they meant. And as soon as I did that, I liked working with them a lot more. So just some of the All Learners Network Common Agreements. I'm sure you've seen these already today if you've been to other sessions. I'm going to let you read those. I'm not going to read them to you for just a minute, and then we'll get going. So just if you could record in the chat, what is the thing that your students struggle with the most when it comes to learning fractions, talking about fractions, working with fractions? What are you seeing as the area where they are consistently struggling? Comparing and ordering fractions, I see. Making improper fractions from mixed numbers and reducing fractions. Comparing and ordering fractions. So fraction reasoning, understanding that a fraction is one number. Yes, that's a huge one. Comparing and ordering fractions, making improper fractions from mixed numbers, multiplying and dividing fractions, knowing which operation to use. Yeah, there is just so much. And you'll hear, I mean, anytime adults say that they liked math until, it always ends in fractions. So I really liked math and I was good at math until fractions. And so, which is hard in and of itself to hear that people think they're bad at math, but also fractions are generally a big stumbling block for people. And there's a lot of things that get tied up in fractions that if we do a little bit of work around reasoning and a lot of work around modeling, we can really clear those things up for students. So we're going to talk about 5 key understandings in this session, and I'm hopeful we'll get through all 5. We only have an hour and 15 minutes, but those 5 key understandings have to do with representation of fractions, magnitude of fractions, creating like units and how that plays into understanding with fractions, multiplication of fractions, and division of fractions. So one thing that I always start with my students so that they know is that a fraction can represent many things. And that in and of itself can be a really tricky thing for them to start to think about. One of the main things that a fraction is that it's a number. So a fraction is a number and it has a specific value on the number line, a specific place on the number line. Many of you probably give the piano away and you've seen kids 10,000 times, right? When you ask them to put 1/2 on the number line, they put it between 1 and 2, or they think fractions are negative numbers, or they just don't know where to put them at all. So one of the big understandings we want our students to have is that they represent a number. Another is that they represent a part of a whole. So we can take that whole, divide it into equal sized pieces, and we know the fraction can be represented that way. A fraction can also represent a part of a group where the group pieces don't need to be the same size. And a fraction can represent a rate or a ratio. So it's important that students have that understanding that fractions take on a lot of meanings depending on what you're using them for. So I'm actually going to break you into breakout rooms really early in this, and I am going to have you work with your teams to think about how, when and how do representations of fractions show up in your instruction? And I only have it going up to sixth grade, you'll see. If you want to continue that and add a column onto the table, you'll see that you are also able to do that. So before we begin that work about thinking about how and when do fractions show up in instruction, I'm going to tell you about the roles that you're going to take on in your small groups. The main reason we're thinking about when fractions show up in instruction and how they show up in instruction is that students have to really be able to grapple with and manipulate these ideas around fractions if we want them to be able to do the really kind of complicated work later. So if our students can't represent a fraction as part of a whole or on a number line, that's going to impact their work as they move forward. So you are going to go into your groups. There are 4 roles. I use these in with my students in 6th grade when we are remote. So far this year, we have been remote, hybrid, and full-time, and we keep switching back and forth. So it's a real roller coaster. And here are the roles that you will take on in your groups. One is that, can you guys see the group roles right now? I should have asked you that first. Group roles. Okay, good. The first one who gets to the breakout room is what I call the screen sharing scribe. And they're the person who's going to share their screen and do the recording on the slide. The second one to get to the room is the communications master. They're going to ensure that all group members have spoken and have been heard. And if you need me for any reason, you'd contact me. The third person to the room is the pacer. They just keep track of the time and make sure the group is moving along. And the fourth person to the room looks for any additional information that's needed and keeps the group on track. You will go into your breakout rooms. I'd like you to introduce yourselves in your breakout rooms. You can say briefly one win that you've had this year. I think that's a nice way to start. And then you're going to go to these slides, and it will be in accordance to whichever breakout room you joined is where you're going to do your recording. So I'm going to give us 5 minutes to do that. And you're just going to think about knowing my curriculum, knowing how kids progress from 1st grade on, how do fractions show up in my teaching, in my fellow teachers teaching, that kind of stuff. It looks like everyone has magically reappeared from their breakout room at this point. Just skipping around, it sounded like people were having great conversations about how this is used, how they use different concrete, representational, and abstract ways to think about like units. Does anyone want to share one that they feel like works really well, or one thing that they've used with their students, just with the full group, that they found to be really successful?
When we start thinking about adding on like fractions, we tend to start with money and clocks because it's, sort of, they can look right at the clock, they know money, it puts it in a context for them, and it's not just like, before we even use the words common denominator, they can think about what half of a dollar is and what a fifth of a dollar is, and come up with an answer to adding those 2 fractions without even a formula or a procedure. And so later, then when we talk about the importance of common denominators, like they sort of have built up to that and have all that, I feel like it makes more sense, and there's less of the 1/3 plus 1/4 equals 2/7, because they just have an idea that they need to be thinking about the size of the pieces.
Yeah, I love that. I think the idea of context is so important, because I think often we say like, okay, we're going to add fractions, and then we just get right to it. And kids are like, what? I don't even know what this means. And I think oftentimes you can get kids, like you said, to do this math that they don't even know that they're doing yet, because they have some frame of reference that works for them. I know how a clock works. I know what it looks like. I've been looking at it for, 6 years in school at least. So I know that I can figure out like, how does that transfer? I very often use pattern blocks. So we've already given like the um, hexagon is always one, so they know the trapezoid is a half. The triangle is 1/6, and they know they would never say like, okay, I know I have two triangles. I don't all of a sudden have um, 12s. Like that doesn't make sense to them. So they're able to really think about it in a concrete way. Like this actual piece of 1/3 plus this actual piece of 1/3, I have two 1/3 pieces now when I put those rhombuses together. And that really helps them. Um, were there other things people wanted to share? All right, I'm going to move us on to multiplication. So, when we think about the keys in multiplication, we think often that by the time kids are multiplying fractions, they have a really clear understanding of what multiplication of whole numbers is. And very often that is not the case. And that is why multiplication of fractions becomes such a tricky thing. Because their whole lives up until this point, they've learned that when you multiply, numbers get bigger. And all of a sudden, numbers are smaller. And that's kind of mind blowing for students. That multiplication has always meant my answer is always going to be the bigger number at the end, or the bigger number is always going to be what happens. And all of a sudden, with multiplication and fractions, our answer gets smaller. So before we even think about going back to multiplication with fractions, there's always a lot of work that needs to happen with just what does 3 times 4 actually mean? What does it actually represent? And doing work with that. My students in 5th grade are always like, why are we doing 3 times 4? We know how to do 3 times 4. Like we've been doing this since 3rd grade. But if they don't have that firm grasp, because oftentimes they become pretty formulaic at this point, or they know 3 times 4 is 12. But if we're having them really think about, okay, three times 4 is 4 groups of 3 or 3 groups of 4, and that's going to equal 12. And thinking about, oh yeah, I'm doing this repeated addition, that really helps them connect to the idea that 4 times 1/3 is me taking 4 1/3 pieces and knowing that's 1/3 plus 1/3 plus 1/3 plus 1/3. So then it makes sense that 4 times 1/3 is actually a smaller value than 4, that it is 1 and 1/3. But we need to do work on that over and over and over again so that students really see and are really able to understand this is what multiplication means, and that connects to my multiplication with fractions. So, if multiplication is the same thing as repeated addition, how does that connect then to 3/4 times 1/3? This should always be grounded in context, just like everything. But just take a second, write in the chat, why might you make 3/4 of a copy of 1/3? Or what might be a situation that makes sense to students? So scaling a recipe, definitely. So I don't want to make my whole recipe, I want to make part of it. We've been doing a lot of that work with ratios this year. Why else might you make 3/4 of a copy of 1/3? I don't eat one whole bag of leftover brownies in a pan. You eat 3/4, and what is left is 1/3. Yep. I always relate everything back to food. My students are always hungry. There's 1/3 of a cake left, and we want to cut it into 4 pieces. Okay. So I think one of the important things that we should think about before we're doing multiplication with fractions, before we're throwing that 3/4 times 1/3 at them, we're just giving them these scenarios and thinking about different contexts so that they're able and having them represent those contexts. Not even telling them that what they're doing is multiplying, not even telling them, showing them the notation of 3/4 times 1/3. We're just throwing different scenarios at them where this might be the case. Eventually, they come to the idea that what they're doing is multiplying. What they're doing is taking a part of a group. So if we think about what those representations look like, I'm sure you guys all have seen the area model many, many times, but it really does make a difference with student understanding. So before we're showing them 3/4 times 1/3, we're showing if we have 1/3 of some, we have a third of it, and we're taking 3/4 of a copy, it's got to be smaller than that 1/3. What's left? Do people have questions about multiplication or things that their students are constantly struggling with multiplication that they want to bring up with the group? Sorry, there's always a lot of awkward wait time on Zoom meetings.
I know one of the things, oh, go ahead.
No, go ahead.
I just know one of the things that my students struggle with is they start to think about multiplication, division of fractions. So especially as they're sixth graders learning division and we're working with word problems, is how they identify which operation to use. Because as they always say, it's so confusing because as soon as you seem like you're multiplying fractions, it's more like division because your answer is always smaller. So
Yeah.
it really confuses them because they have to sort of think about it differently now.
They do have to think about it too. Yeah, because well, and one of the things that fractions is rooted in is the idea that fractions are division.
Right.
So when you're
right. Yeah.
Really hard to find.
Yeah. So it's a struggle from the get-go.
It is. So one of the things that really, and I'm sure you do this already, but really helps students is that if you numberless word problems can really help so that they're just thinking about context first. So removing any numbers from the problem and them just thinking about, so what's actually going on in this situation? And then when you do insert the numbers, thinking about, don't have them like calculate it all. So really reasoning about, draw this first, draw what is happening first as best you can in any way that you can, and think about, given this context that I've already figured out what is going on and this representation that I've drawn, what is the thing I need to do to it? And that I find is the most helpful for students. So I always have this, like, they're not allowed to actually calculate anything until they've told me what's going on and they've reasoned about what that might look like visually. Rebecca, were you going to say something?
I was going to say the same thing about them distinguishing what operation to use, and your point about anytime anyone seems confused, we start a picture. But sometimes, especially when you're finding parts of parts, I think it is just more confusing to draw that picture for them than it would be. But what happens, or what I find happens, is they start to recognize those patterns and those algorithms that we were taught, even though we're not teaching them. Like, they start to notice, hey, I just multiply the numerator by the denominator or whatever. And then they don't go to the model, right? Like, then it's like pulling teeth to get them to go back to the model. And it's just frustrating because I know if they would just bank on their conceptual understanding and go to the model, they'd probably be more likely to get through the problem. It's just that they start to see those things and want to just, solve it that way. I mean, other than slowing them down, I don't have an answer. I just think they don't want to draw models anymore, right? Like, as the kids get older, I think they're not excited about it, but.
Yeah. And I think part of it too is this, like, often as they get older, they see like models as something that might be babyish, or that they feel like is something that you do if you don't understand what's going on. So I think it's just this, like, systemic thing we need to work on, where it's like models need to be seen as kind of the pinnacle of understanding rather than the thing you need if you don't really get it. And I think the more we can encourage the teachers all throughout the grades to think, modeling is the piece that really lets you understand math, that really shows you a deep understanding, the more students are going to be apt to do those models.
I also think there's value in thinking about how to communicate that to families and having a whole, because families don't, I mean, I didn't learn the way I'm teaching necessarily, and I don't think that they necessarily understand it. So when a kid does struggle, their parent is trying to teach them the algorithm, and I think kids start to think, to your point, that that's cool, right? Like, oh, look, that's quick, it's easy, I can just, but they don't, when you hear people try to explain an algorithm, it sounds like gobbledygook, actually, so I think I think we're shifting. I think education is shifting that way, but I don't think we're completely there yet. Hopefully it doesn't shift back, but I agree. I think the modeling is essential.
Modeling is essential. And I'll say, I mean, I don't know how many of you right now are in what phase of education right now, if you're remote or hybrid or fully in person. But I remember seeing memes when schools first closed that was like, now parents get to teach the good way of doing math. And I was like, oh God, oh no. Because realistically, it's funny because parents will say, like, I was never good at math, but they should be learning math the way I learned it, which is interesting because it generally causes more confusion. So I think we're in a particularly difficult time now because many students are getting more instruction at home, which is very formulaic and algorithmic, I guess. So yeah, I think you're right. I think education is shifting that way. I think a lot of it has to do with teacher comfort in understanding those processes and what's actually happening. But I think the more we can hold up models and visuals and concrete understanding of these things as kind of a sign that you really understand the math, the more students will see that as a positive to use those things rather than something we're forcing them to do. All right. So if we think about division is then the opposite, right? So multiplication, all of a sudden numbers that used to end up bigger at the end, sometimes now they're smaller. And so we have to go back and really ground things in what does division actually mean? And division, just like subtraction, has that tricky component where division actually means two things. So we can think about, there's the partitive, fair share type of division, which we think about if we're going to divide 8, how many go into each group? So what's that fair share to each group? And then we also think about quotative or measurement division, where each piece is the same size. So how many of those pieces? This is something that is really worth spending the time on before going into division with fractions, thinking about this with just really small, reasonable whole numbers so that kids really remember that division actually means two things, and it's very different given the context. So oftentimes it means a departure from the textbook. Most of this stuff means a departure from the textbook, but I think it's really worth doing because students really need to see, oh yeah, this means two things, because it plays a huge difference in their understanding of what is happening with actual division. So if we think about division, when we're thinking about partitive division, we really want to go back to that emphasis on magnitude and think about what models and representation can help students visualize the context. So in a relay race, students are going to run a half a mile. If they all run the same distance, how far will each student run? this would be something that is a division problem with fractions, but students will solve it in all different ways without knowing that it's a division problem if they have those models and representations in front of them. If our first goal with the students is to say, okay, write an equation that goes along with this problem, then they're just going to start to number grab and calculate rather than really think about the context of the problem. There's a thing in math research, I guess, that you might have heard of called students have this compulsion to calculate, where they see numbers and they just grab them and they feel like they have to do something with them. Like, I guess I'm adding, I don't know. Or we've been multiplying for the past 3 weeks in school. I guess we're just going to multiply these numbers. And so it's important to say to students, just as in multiplication, okay, what's actually going on here? And how can you create models and representations? I'm going to put you into your breakout rooms just one more time, and you'll see that these division slides are right in there. And in your breakout rooms, I would love you to have the discussion about these problems that I have here, thinking about what models might students use? What models might you start to expose students to, or representations, or what manipulatives might you have for students so that they're able to kind of think about, how could I solve this problem? And why does my answer get bigger sometimes when I am dividing? So why is it all of a sudden that if I take 4 and I'm dividing it into a half, that's very different than taking a half and dividing it by 4. And given the context, what is going on? I think we are all back. I heard some really good discussions in the groups, and I'm wondering if people want to talk about the ways they would model and represent these different problems to help students, visualize the context.
I would act them all out. I think it's worth it, especially with 4th graders. But, when we're at the end of our unit, we'll definitely act those out. But I think they're worth going outside and, spreading kids out and having them actually feel what it feels like to run the 1/4 mile or whatever, or share the cake and make the cake and bring it in and share it if you can. I don't know if you can do that during COVID, but bring in a bag of almonds and divvy it up. As long as they don't eat them, that's fine. I think those are great examples, and I hope that we get a copy of the problems, because I don't want to have to recreate them. So
yeah, awesome. I can just put this slideshow in the chat.
Thank you.
I love the idea that you act out them out, and I love that you said it's worth the time. I think any of these things, like if we can say, you know what, like maybe I'm not going to make it through this curriculum, because honestly, I've never met a teacher once who has made it through their math. Have any of you ever made it through your math curriculum in a year? No. Right? Mm-hmm. So if we can say, like, it's worth taking the time because these are such important concepts. It is so important that students aren't just becoming these little calculators that are trying to just figure out what to do and then have an algorithm and solve it. I think that we're going to see so much, their math is going to become so much stronger. I know Ken Gross, who started BMI, found that oftentimes one of the biggest reasons students struggled in calculus was because of misunderstandings around early number sense, particularly around fractions. And so fractions, if we want our students to be doing this higher level of mathematical thinking and this reasoning and have all these doors opened up to them, fractions is something that is 100% worth taking the time on with everything, because you have to have a deep understanding of them in order to do anything once it gets to really high levels of math.
Mm-hmm. Can I say something to that real quick?
Oh yeah, please.
So one thing that I've been using, I've got a couple boys in my room who are like doing math every second of the day. Like during reading time, they're sneaking out their pieces of paper and writing out these decimals and passing them to each other and trying to get as advanced as they possibly can. But anyway, we have our coach working with them, but which is calming them down a little bit. But one thing that I did recently was I came home and spoke to my son who just finished calculus at the high school level. I said, write me up 3 problems with visuals. And I brought those in and said, here, try to solve it. And they were like, that sort of put them at a stop, a place to stop. And I said, if you can conceptually understand division and multiplication and work at it step by step, then you will work your way towards solving these types of problems, because I think every once in a while you're going to throw in there what's going to come at them in 8th grade, or what's going to come at them in algebra, or come at them in algebra 2 or calculus, just so they know that it may just humble them a little bit, especially if they're giving you qualms in 5th and 6th grade as to the importance of drawing a picture.
Yes.
Yeah.
And I think I heard someone in one of the other groups saying that like it becomes a struggle, and we said it in the full group too, that to say like kids don't want to go to those models again, and often what we say is they don't want to go back to the models. So I think one thing that we really need to consciously do as we're working through these, as we're working with fractions, is they're never actually going back to models because we've never let them disappear. So there's always some visual, there's always some representation in literally every problem that we're doing, so that it's not like we're going back. It's like that is an ingrained part of our mathematical reasoning, is that there are these models that are a really important piece. We're always visualizing what's going on that note, we are out of time. It is 3:00. If you go to your final slide, in that participant slide, that has a lot of links. And so about getting in touch with the All Learners project. So there's a lot of links here. They should be, oh, actually, you know what? This is funny. I couldn't figure out how to put a PDF into my slideshow because Google Slides won't let you do that. So it's linked to a PDF of this same document with the live links in case you want them. So that'll take you to the live linked document, which is just in my Google Drive. And make sure to get in touch with ALN if you need anything. Like I said, I just really appreciate you coming to this workshop today. I know this is a crazy year and we're all tired and exhausted and working at 150%. So thank you all very much.